All right, we're going to go through Swift in 10 minutes. So Swift is the next evolution of Objective-C. Objective-C was an evolution of C. So Apple made its own object-oriented version called Objective-C, and then they made a much cleaner language called Swift. It's a different language, but it really has a lot of the same underpinnings. Um, Compiles to the same behavior. Swift is modeled somewhat on JavaScript. So if you've done JavaScript, you're used to seeing something like this. This is valid JavaScript. Var to declare some variable. It's going to hold a little bit of data, and this one sets it to 0. And so the language automatically knows this is probably going to be a number, so it'll set it as an integer. And you see there's no terminating symbol here, just a new line, just like in JavaScript. You could, if you wanted to, put multiple statements and separate them with a semicolon, but that'd probably be weird, but it's legal. So not like C or Java, you don't have a semicolon. You'll see here, this is instantiating an object, so there is no new keyword, none of that memory management stuff that you do like in C++ or Java. Just instantiate the new object. You'll see up here for class, it looks a lot like C. Declare the class, and then put a colon between the superclass. So this view controller is a UI view controller. That's the superclass, that's the base class, and gives the basic functionality that every view controller is going to have. And after this is a comma, and then a list of protocols. These protocols are like interfaces in Java, so you implements. In Java, you put out the implements keyword, but here you have the comma. And you can see these protocols are just a list of functions that you need to have in your class somewhere. So by having that protocol, you're letting the compiler know that you do have those functions somewhere, and you can pass them to a method that takes this as an argument. All right, we're about a fourth of the way through, so move along quite quickly here. And if you don't get everything, obviously you can go into detail on each of these in other training modules. But this is just to give you a quick introduction. If people have programmed a lot, you can kind of see what's up with this language. Another thing that's up here is this attribute. So attribute is basically just a keyword for the compiler, tell it to do some special things. In this case, this one tells the compiler to connect our variable here to something within our screen design. So in our screen design, we've got a bunch of objects, and each of these needs somehow to be connected to code so we can manipulate them. That's what that does. And we'll look here at what is similar to our main. So if you're in Java, you have a main, or C, you got a main function. That's where the program starts. That's what this attribute does. It actually boils down to creating the main and tells it to call into this app delegate. So this app delegate is where your start of day is for your application. And that's what the main is about. Here we'll see a variable. And we'll see that it does have a colon, so that tells what type it's going to be. And it's going to be a UI window. But after that, we see a question mark. What's that all about? Well, what that's all about is null pointers. A lot of times programmers would try to use a variable, but they forgot to initialize it. And the processor, when it tries to go and access the data, there's nothing there because it was the wrong address. And you get these null pointer exceptions. And so in order to avoid having those, Swift added some language syntax so the programmer can somewhat avoid those and catch those at compile time rather than runtime. So if you put a question mark, then the programmer is saying, I know this possibly could be nil or could be null. It doesn't actually refer to an object yet, and I'm allowing that. So you need to put the question mark so you can allow that to happen. If we go back over here, we saw that these had an exclamation point. What that is saying is, we are absolutely sure this won't be null. This is not going to point to a non-existent memory location. So we're putting an exclamation point. When the compiler goes and evaluates the code and looks for null pointer type bugs, those class of bugs, it won't find one. It'll say, that's okay, we know this is going to be valid, so we can ignore any potential bug. It's interesting because this is a var. Vars are things that can change. So you could assign toolbar A to a different object, and If we look down here, we might see a let. So here's a let. Lets are things that don't change. So this clock time is just always going to point to this particular variable. So this is like a constant in other languages. Not going to change. And that, again, lets the compiler know while we're working with clock time, we don't have to worry about null pointer checks because, hey, it's not going to change. Here's another example of a let. These, again, don't change. It's final within this particular class. These IB actions, similar to what we saw before with the outlets, that's how you actually connect a button press to a function in your code. One interesting thing you know from other languages probably is try catch. So if you're going to have an exception rather than having the program crash, you go ahead and catch it. So in Swift, there's a do catch, and then you have try keywords on each of your statements. And then you have the simplicity error object you can print out. Here we're using the print, and in this case we're not passing in a parameter. We're not naming the parameter. In some cases we do name the parameter. So if we look up here, these all have an underscore which says we can use it positionally like we're used to in other languages. But this one, we see the string method called data does take parameters using and allow lossy conversion, and we are naming those. But if we come down here, we're using the print, which does the log to the output log over here. And we'll see that one is not naming that parameter. There's some additional parameters. You know, you could put a separator or something. Or a terminator, either one or both. So those are optional. We'll just look real quickly here. So when you declare a function, if you put in an underscore, that says that parameter is going to be positionally sent in. So don't put the name of it. But these other ones, you do put the name. These have a default. But if you don't, but you're allowed to put it if you want to. All right, we're only about 3/4 the way through. So let's quickly go through here. Again, creating a class, has some variables. Calling a method in the class, we use the period notation like we do in other languages. And you can pass it in. This greet passes in naming the parameter. Greetings passes it in positionally like we're used to with other languages. So greet, we'll see it has a name. And greetings has that underscore. That just says you do it positionally. But then we refer to it by its name. Here we can see this has a return type. So you see this arrow syntax with return type of string. We'll see you can also give a default. So if they don't pass it in, then it's going to default to a certain value. It's kind of syntactic sugar. This one's kind of neat. You can actually pass in, return a tuple. So in this case, we're passing in an array, but we're returning more than one variable. So it's called a tuple, it's multiple variables. So in this case, the return is actually 2 variables. So let's go down and see that being used. Min max. So bounds, we have one variable that we've created here, refers to the results. Now to get to the actual values, bounds.min and bounds.max. So you can access what's in that tuple. Well, we only got a few minutes more, so we'll quickly look through, see what else we need to do. You can pass in a list of objects, sort of like in other languages. Then they have in-out. So in-out is basically passing by a reference. So if you did a lot of C programming, you're used to this. In Swift, like other languages, the int and the double and type like that string are immutable. So when you pass them in, you're not changing the object. But like most languages, you're passing in a reference. So this in-out, that's where we get into reminiscent of C programming and Objective-C. We have to use the ampersand to give the address. So it's allow them to reference that object, and then they can actually change the data. So that's about 10 minutes. That's about all you need to know. At least open up some code and start digging through it.